Hello everyone, it's Benny, and welcome to video 3.5. In this particular video 3.5, we're going to be talking about mesh creation, the act of taking 3D data and sending it to the GPU for it to draw it or do whatever. And that's what we're going to be doing in this video. However, this is one of two video 3.5s. In the other video 3.5, we're going to be talking about shaders, which are programs for the GPU that will actually do some processing on this 3D data. Now, it doesn't matter which one of these you go through first, you're going to have to go through both of them anyways. So, just pick one, and once you've gone through both of them, we're going to move on and do some more interesting things. So, if you'd rather start with shaders, go ahead, move on to the other video 3.5, and, well, okay, they're all gone now. So now let's actually start with mesh creation. So I'm going to create a new class for our mesh. I'm going to call it capital M mesh, and since it will have a destructor, I'm also going to have a copy constructor, an assignment operator, and the destructor will be virtual. Now this is checked, so I think I have just about everything I want set up. So I'm going to go ahead and create. I do want to add it to the project. I do want to add it to the build. And I'm just going to delete the default copy constructor and assignment operator, like always. And I'm going to move the default copy constructor and assignment operator to private. I'm going to make this particular one void, just so I don't get an error. Well, not an error, but a warning. Still, equally annoying in my opinion. And there. And our mesh is going to have one public method, void draw. What that's going to do is it's going to take our mesh and it's going to, well, draw it with the graphics card. It's going to send it through that big gigantic pipeline to be produced into a final image. So mesh : draw. And there. I'm going to go ahead and delete the little destructor mark. I'm going to delete the little constructor mark. And whoops, just tab over here and here. And there. So it looks like the classes are, or the class is organized in the way I want it to be. In fact, I'm going to tab everything back one just because that's my preferred. Well, I prefer organizing my classes like this. So, there. And what we're going to do is we're actually going to create another class because, like I said, the mesh is going to have to take some data and send it to the GPU. We're going to have to represent that data some way. So, since this is a tutorial, and since it really is genuinely a good place to start, I'm going to take our initial piece of data and start just with the internal format that OpenGL is going to need us to convert to eventually anyways. So, and I'm doing this partially, like I said, partially because it's a good learning experience. I mean, if you get to implement the data form they're expecting in code, I can only imagine that's going to help you understand it. And two, it's just genuinely a good place to start because you'll usually want to start with as close to the format they expect as possible and add things as necessary so that you need to do as little processing on the data as possible for performance reasons. So, yeah. And the way I expect this is with a vertex. So I'm going to create a class for that. I'm going to have some of my public, protected, and private sections. What protected spelled correctly, though. And really this is just going to be a data class. I'm going to make it, really this could be a struct right now. I'm making it a class just because eventually, in fact, and I mean really eventually, as in probably not even in this tutorial series eventually, I'm going to want to add some functions to this and make it, do some things. But for the most part, in this tutorial series, it's just going to act as a struct with getters. And if you want to, you can just make this a struct. But, I'm going to make it a class just because I like being forward like that, I suppose. So how are we going to represent the data in a vertex? Well, the way OpenGL represents the end data we're going to need to create is formatted like this. There's 3 points, and actually probably should have said this before I created the vertex class, but oh well, now you'll understand why we're making the vertex class and what it's going to have in it. the internal format that OpenGL expects us to eventually convert to is an x, y, and z coordinate, and they all must be between -1 and +1, and it expects 3 of them in sequence to represent each triangle. And our vertex is just going to be one of those 3 points. So it's going to have an x, y, z coordinate between -1 and +1. And the way I'm going to represent this is using OpenGL's math library. So I'm going to include glm/glm.hpp. That's the header for the OpenGL math library. And you should have that linked from the setup video, or at least included, or whatever. You should be able to use it, I should say. It doesn't need linking. And that's how we're going to represent the data. We're going to represent the xyz coordinates with a 3-dimensional vector, a vector 3, which is an xyz coordinate. Think of it like a 3D point if you don't know vector math. So glm::: vec3. And I'll call this pos for position. That'll be the vertex data for now. So I'm going to create a constructor for this. It's going to take in a position, glm, a constant glm vec3 reference position. And I'm just going to implement the constructor here because it's simple enough. Just going to set this arrow position to position. And there, nothing fancy there. It's just, like I said, this could be a struct right now. I'm just not making it a struct because I'm eventually, as in not even in this tutorial series, going to use this for, well, as a class. So yeah, and this is going to be our data. So our mesh, what it's going to take in its constructor, is it's going to take in a list of these vertexes. So it's going to be a vertex pointer vertices. And it's also going to take an unsigned int num vertices. Now, although it will take these vertices in groups of 3, so like every 3 vertices will be a triangle, you aren't limited to 3 vertices. Like I said, like I said in the original video 3, yeah, I guess that's a good way to describe it. Like I said in the original video 3, you will eventually, well, we will in this video be sort of delimiting, that's what I'm trying to say. I have trouble with that word, sorry. Delimiting these into different groups. We'll say, okay, there's this much space for every block of data. And if we set that to 3, then everything's just going to work out well. So what I'm trying to say here is, yeah, we can have a whole bunch of different triangles in here, if we really want to. It doesn't have to just be one triangle. We can have a list of 8,000 triangles, if 8,000 was a multiple of 3. So, yeah. Anyways, now that we have all that, let's actually create, first off, before I forget, let's take this and move it to mesh.cpp and put it like that. And let us actually put in the data for this. Now, I'm going to include OpenGL, so gl/glue, because that's what's loading all the OpenGL functions. And I'm going to actually implement the data. So I'm going to have a gluint, because that's how OpenGL refers to all the data it has on the GPU. And this gluint I'm going to call m_vertex array object. This is the modern OpenGL way of referring to mesh data on the GPU. And I think it's a fair warning that this particular feature was only officially included in OpenGL 3.0. It's still fairly well supported in earlier OpenGL versions, such as OpenGL 2.1 and whatnot, by extension, which Glue will find for you, so you wouldn't need to worry about that. But still, it's worth bringing up that this particular method of creating OpenGL data may not work for you, depending on what version of OpenGL you have and what extensions it has. So, just a fair warning. So, it's going to have a vertex array buffer object, and I'm going to have another gluint. This one's going to be an array called vertex Yeah, I'll say vertex array buffers, I guess. Why not? And they'll have a size of num buffers. And the way I'm going to sort of specify this is with an enumeration, because I'm going to want to be able to refer to every single one of these vertex array buffers. And this one, and in this case, I'm just going to have one, but surprise, I'm eventually going to expand this. And this one I'm just going to call position VB. And whoops, and comma. And at the end, I'm going to have num buffers, so that we always know how many buffers we have in this enumeration. And there. And finally, we're going to have some unsigned int, I'll call m underscore draw count. That will tell OpenGL how much of this big gigantic vertex array object we're going to create we want to draw. And well, of course we're going to need to keep track of that, because OpenGL doesn't keep track of how big this is. So think of this like almost as if how big it is, except not exactly, because we're keeping track of how much we want to draw and not the exact size, sort of. I don't know, that's not a good way of thinking of it. Point is, you'll see how this is used once we actually use it. It'll make a lot more sense then, but for now we need to keep track of how many things we're going to need to draw. In this case, it'll be how many vertices we need to draw, but you'll see. So, now it's time to implement the constructor. Okay, so now that we got our data defined, it's time to actually use it to represent a mesh with OpenGL. Now the very first thing I want to do here is I want to set our draw count, which again I'll explain more about when it makes sense, to the number of vertices. Because right now we're going to be drawing based on a per vertex basis how many vertices we want to draw. There are other ways to draw, and we'll look at that probably later in this video, but for now that's how we're going to draw. Again, it'll make sense once we actually start drawing, but yeah. And now it's time to use these vertex array objects and these vertex array buffers. So, first off, I'll gl gen vertex. There we go, vertex arrays. Now, this takes in two parameters. First off, the number of vertex arrays you want to generate. I just want one, thank you very much. Don't need any fancy multiple vertex array object. And it'll take in the vertex array object, where we want to store it. Right there. And with that, we now have created space for a vertex array. Now, in order to actually start working with it though, and of course in the destructor though, I probably want to delete it, so gl delete vertex arrays, one m underscore vertex array, object, not buffers. So we've generated a vertex array object, we've deleted a vertex array object, now it's time to actually use it. The way we use it is we bind, and then bind vertex array, and then we pass in the vertex array object. And the way this works is once we've bound it, then any operation that would affect a vertex array object will affect this particular vertex array object. And then the way we stop doing that is bind vertex array 0. And that means that any operation that would affect a vertex array object after this point no longer will. So it's kind of an interesting way of dealing with these handles, but it works. So now, once we have our vertex array, we want all our vertex buffers to be part of it. Because I didn't mention that. I'm sorry. The way OpenGL refers to data on the GPU is with buffers, which is just any block of data on the GPU. That's a buffer. And that's how we're going to have to handle our data, with buffers. So gl gen buffers. That's how we get some buffers, which are just blocks of data on the GPU that we can write to. Now I want to generate the number of buffers, and I want to pass in right here, I completely forgot, the address of mVertex array object, because it takes in a pointer. So anyways, for num buffers, I want to pass in mVertex. Oh, and I believe this takes in a pointer too. Jeez, I'm just off my game today, I suppose. Now this takes in mVertex array buffers. That's what I'm going to pass in. And this is already going to be stored as a pointer in the class because it's an array, so I won't need to say the address of that. No, don't put an ampersand in front of that. That would be bad. And that will just give us a whole bunch of different blocks of data on the GPU for all the buffers we want to generate. In this case, it's just one, but hey, at least it scales nicely. So, now I'm going to bind buffer. I'm going to bind the position VB. So, there. Now, and again, this works pretty similarly to the vertex array. Now, any OpenGL function that would affect a buffer will now be affecting the one in our position. Wait. Bind buffer, vertex array buffers, subposition VB. Good lord. And you know what? I'm going to go ahead and take a really quick pause break here so I stop making silly mistakes like that. So, one moment. Okay, I'm back, and now let's fix the final silly mistake that I made. Bind buffer takes in two parameters. Yeah, it takes in the buffer you want to bind, but keep in mind, buffer is just an arbitrary block of data on the GPU. It can mean absolutely anything. So in order to get something meaningful out of buffer operations, we need to tell OpenGL how to interpret this buffer. So I'm going to pass in a constant from OpenGL, GL array buffer. And what this will tell it to do is it will tell it to interpret this buffer of data as an array. So any operation we do after this will think that this block of data that we're referring to with the vertex array buffer, subposition VB, it'll think that it's an array. So there. So now we got an array, which is eventually going to store all our vertices. So now we got an array, what do? Well, what we want to do is we want to put all our vertex data in the array. So, in order to do this, we just use the method bufferData, which does exactly what you think it does. It takes some data and puts it in the buffer on the GPU. So essentially this is just taking, if you want to think of this in hardware terms, this is taking some data from RAM and moving it to GPU memory. Technically that's not always the case because integrated graphics cards also use RAM as GPU memory, but you know, you can think of it like that if you like thinking in terms of hardware. So now we also want to tell it how to interpret the data we're sending. I want to, again, interpret this buffer of data as an array. Now we want to take in how big is the block of data we're sending, because it's still treating this as just blocks of data. So here's how I'm going to do this. I'm going to take num vertices times the size of vertices, times the size of vertices sub 0. And the reason I'm saying size of vertices sub 0 rather than just times num vertices rather than just size of vertices, which in theory should give you the number of bytes that represents this, which is what I'm ultimately going for. You know, let's start that over. The reason I'm doing it like this is, well, this will give me size of vertices sub 0. What's vertices sub 0? Well, that would dereference the pointer. That would just give me a vertex, the size of the first vertex. So there, it knows. This will ultimately give me the size of a vertex times the number of vertices, which will ultimately give me the total size of this block of data, the vertices block of data, which is what I'm going for. But the reason I'm doing it like this, rather than just saying size of vertices, because that's what size of does. It gives you the size of some piece of data, is because I'm passing it in by pointer. Since size of is a compile time operation, it won't know how big vertices is, how many elements it has in it. So this wouldn't give me a correct result if I did it like that. That's why I'm doing it like this. Hopefully that makes some sense. Anyways, so now that we know how big the block of data is, we need to know the pointer where we start at, which would just be vertices. And finally, we want what is called the draw hint. This is a hint of where OpenGL should put the data in the graphics card. So for example, if we tell OpenGL we're never planning on modifying this data, which is what I'm going to say, we do that with GL static draw, then it's going to find some location in memory where it's not expecting the data to be changed. It can make some certain optimizations depending on, well, if the data is going to be constantly changed or not. If it's never going to be changed, you can put it in some place that's really fast to access, but maybe not so fast to write to initially. That's the draw hint. Okay, cool. So with that, we finally, takes a bit of explanation, but it's really not that, it's not that complicated what's going on here. With that, we've finally taken our data, we've moved it onto the GPU. Now, we have to tell OpenGL how to actually interpret this data once it's trying to draw it. And the way we do this is with a GL vertex attribute array. Whoops, and I forgot a word here. GL enable vertex attrib array. So here's how this works. This will divide our all our data into attributes. And in this case, I'm just saying all of our data is this one attribute. So, well, every piece of data in here is an attribute. It's not organized like here's one attribute, then another attribute, then the first attribute again, then the second attribute again, not like that. Let me just stop for a moment because I'm getting flustered. One moment. Okay, let's forget about vertex attrib arrays for a moment. Let's just focus on what we have. Right now, we have a buffer. We told OpenGL that this buffer is an array, so it knows it's an array. And we've also told OpenGL that to put all of the vertex data, all of our vertices, into this array. So it has all our vertices, and it knows that it's an array of them. But there's one more thing that we need to tell OpenGL about. And that is what it likes to call vertex attributes. If you have your vertices in a class, like I do, then this is nothing more and nothing less than the member variables of the class. For example, I have a position. That's our vertex attribute, and that's our only vertex attribute. If I create another variable here, like the glmvec3 color to represent some color at every vertex, then that'd be another vertex attribute. So, alright, you understand that? Hopefully understand the concept of vertex attributes. I know I haven't explained how they're used yet, but hopefully you at least understand what they are. Okay. So now, here's why that remotely matters. When OpenGL, or rather your GPU, is actually drawing the data, it needs to look at it as a sequential array of data. And that includes every individual attribute. It has to look at every individual attribute of your class as a sequential array of data. And that means if I have something like this, where I have glmvec3 position and color, well, if I create an array of these, it's going to look kind of like this. Position, color, alternating between position and color. And that's not a sequential array of data. This is where vertex attrib arrays come in. They allow OpenGL to tell the GPU how it could look at this as a sequential array of data. For example, it could say, hey, start at the beginning, then skip every other piece of data, so that you have an array of just positions. Then, hey, start past one, then skip every other one, so you have the array of just color. That is the concept of vertex attrib arrays, and that's why they're useful. Now, in our case, we do have an array of sequential data, so most of that doesn't matter to us. But we still need to tell OpenGL, hey, this actually is a sequential array of data, and you don't need to do anything special. Okay, hopefully that clears things up. Now let's actually create the vertex attrib array. So I want to GL enable vertex attrib array 0. So this tells it, hey, there's going to be some attrib array, and this is going to be the data in attrib array 0. Now how we know what data is in attrib array 0, that has to do with the shader, and we'll talk about that there. Well, really we'll talk about it when all this comes together, because you can't make much sense of it just by looking at one part, but, yeah. So, we have a vertex attrib array. We know we're telling OpenGL how to read one of our attributes as an array. So how do we actually tell OpenGL to do it? Well, we've told OpenGL there's going to be some attribute, and we've told OpenGL that we're going to tell it how to read one of our attributes as an array. Now we have to tell OpenGL how to actually read that as an array. So GL vertex attrib pointer. That's how we tell OpenGL how to look at an attribute, well, as an array. Or what does it need to skip, what does it need to do to read in each individual attribute and ultimately view the attribute as an array. First off, we need to tell it which attribute array it's part of, well, which attribute array I'm telling it how to interpret. In this case, we have 0, so just 0. Then we need to tell OpenGL how many pieces of data in here. Well, let's see. We have a vector 3, so there's 3 pieces of data in our position. Now we need to tell OpenGL what type of data these 3 pieces of data are. And I'll just tell you, GLM stores them as floating point data, so we'll store it as GL float. So we've told OpenGL that each individual attribute has 3 pieces of floating point data. And that's accurate. That's what our position is. It's 3 pieces of floating point data. So we have 3 floats. Now we need to tell OpenGL if we want to normalize it. I've never used this, so I'm just going to set it to false. And this is where we can have that sort of skipping effect. This is how much data it will skip before it finds the next attribute. Again, our data is a continuous attribute array, so this is just going to be 0. And this next one's going to be how much it needs to start from the beginning to find the first attribute. Again, this is the only attribute, so this is just going to be 0. It's going to be the beginning. That's how vertex attribute arrays work. And with that, OpenGL finally has enough information to not only have our data on the GPU, but has all the information it needs to be able to draw it. So now let's actually implement the draw method. I'm going to take my bind vertex array, or vertex array, and, whoops, not delete the brace. I'm going to enable it here, or bind it, and then I'm going to unbind it at the end of the drawing, because, well, all we want to do here is we want to draw our big, gigantic array of vertex attributes. And drawing it is really easy. Say gl draw arrays. Tells it to draw an array of data. And it needs a little bit of information, a little bit more information about how exactly you want us to draw it. First off, there's a mode. This is basically triangles and variants of triangles. So, you know, you can either draw triangles, you can draw individual lines, which, you know, I guess that's kind of not triangles, so you don't have to draw a filled shape if you don't want. You can draw individual lines. You can also just draw a point at every individual vertex if you really want to. For the most part, you're going to be drawing triangles, so just say geo triangles, or geo triangles. First, this tells it where you want to start. If you want to start at the beginning, if you want to start several elements into this array, because remember, it's reading our buffer as just a giant array of data. I'm going to say 0, I want to start at the start. And finally, how much do you want to read? How far do you want to read? So, where do we end, essentially? I just want to end. This is where the draw count comes in. Now this is telling us, in this case, how many vertices to draw, since we are indeed drawing based on vertices. If we're drawing differently, we might not set this to the number of vertices, but in our case it is. This is just telling it to draw all the data we have in the buffer, because, well, all the data is all the vertices, so if you tell it to draw all the vertices, it's drawing all the data. There. And with that, we now have drawing. So, now we should be able to include mesh here, mesh.h, excuse me, and set up a basic example mesh. So the way I'm going to do this is I'm just going to create some vertex vertices. It's going to be an array. It's going to have some data in it. So I'm going to specify 3 vertices, just going to draw a single triangle. And it's, of course, going to take in some glm vec3. So that specifies 1 vertex. I'm just going to pass in 0, 0, 0 here for the time being, just so that, well, you know, don't have any bizarre errors, I guess. And there. So now we've got 3 vertices. Now what do we want to draw exactly? Well, I'm going to draw a triangle that takes up half the screen. So here's how I'm going to do. Right. Remember, OpenGL coordinates are from -1 to 1. I'm not caring about the z component, because that's just going to be 0 for everything, but x and y I do. -1 is the left of your screen, 1 is the right of your screen, so left to right. 1 on y is the top of your screen, -1 is the bottom of your screen. That's how OpenGL coordinates work. So I'm going to start one vertex at -0.5, so if this is center, it's going to go -0.5, and I want it to go down, so to -0.5. So it's making a vertex about right here. Next vertex will want to be the tip of the triangle, so it's going to just be at 0 and up 0.5. So it's going to be right here. So one vertex here, one vertex here. Finally, I want one vertex over here, so it's going to be at positive 0.5 and negative 0.5. So there, one vertex here, and a vertex here. That should be a triangle that takes up about half the screen. So, with that, let's create the mesh. It's going to take in the vertex array, which is vertices, and it's going to take the number of vertices. I'm just going to calculate this using the size of operator. So, since I do have the total number of, or I do have the vertex array initialized here, the size of can determine the total size in bytes of it, so I'll take the size of vertices, and I'll divide that by the size of vertices sub 0, because after all, the total size of something divided by the size of one part of it, the total size of an array divided by the size of the number of bytes of an array divided by the number of bytes that one element takes up should give you the number of elements in that array. Whew. There. And that should give us a mesh. And here I should be able to say mesh.draw. And unless you have a really lenient graphics driver, when you run this, you probably won't see the triangle actually drawn, because we haven't defined any shaders. If you have a lenient graphics driver, you might. But let's see. Outside of class definition. Did I forget a semicolon at the end of some class or something? Interesting. Oh, because I put a semicolon. Right. Now let's build. Okay, now let's run. And as you see, I do not have a lenient graphics driver, so I don't see anything. But just to prove to you that this is working, I've already done the shader portion at this point, so I'm going to include shader.h. Going to create a shader, which takes in basic shader. Wait, excuse me. ./res/basic shader. So there's the shader we created in the other video 3.5. And if I bind this shader, so we're now drawing with this shader, the data should go through the pipeline, and we should see a red triangle. So there you go, the data is working, and so is our shader, because we told it to only output red pixels. So there you go. Hope you enjoyed, hope you learned, and I'll see you either next time, or if you haven't seen the other video 3.5 on shaders, then I'll see you then.